Imagine trying to measure the speed and position of a tiny particle. You might think, easy, just use precise instruments. However, the universe has a fundamental limit on how much we can know about these properties simultaneously. This is the essence of Heisenberg's uncertainty principle. Discovered by German physicist Werner Heisenberg in 1927, this principle revolutionized our understanding of the subatomic world. It states that the more precisely we know a particle's position, the less precisely we can know its momentum, and vice versa. This isn't a limitation of our instruments, it's a fundamental law of nature. No matter how advanced our technology becomes, we can never outsmart this principle. The uncertainty principle has profound implications for our understanding of reality, suggesting that at a fundamental level, the universe is inherently probabilistic. To grasp the uncertainty principle, we need to understand the relationship between position and momentum. Position is simply where an object is in space, while momentum is a measure of its motion, its mass multiplied by its velocity. In classical physics, we can easily know both an object's position and momentum with arbitrary precision. However, in the quantum realm, this becomes impossible. Imagine trying to pinpoint the exact location of an electron. To see it, we need to bounce light off it, but light carries energy and momentum, which disturbs the electron, changing its momentum in an unpredictable way. The more precisely we try to measure the electron's position by using shorter wavelength, higher energy light, the more we disrupt its momentum. This interplay between position and momentum is at the heart of the uncertainty principle. The uncertainty principle forces us to abandon the deterministic worldview of classical physics. In the classical world, if we know the initial conditions of a system, we can predict its future with absolute certainty. However, in the quantum world, the uncertainty principle introduces an inherent fuzziness. We can only talk about the probabilities of finding a particle at a certain position or having a certain momentum. This probabilistic nature of reality is one of the most shocking and counterintuitive aspects of quantum mechanics. It suggests that the universe is not a clockwork mechanism, but rather a cosmic dance of probabilities. The uncertainty principle is deeply connected to another bizarre quantum phenomenon, wave-particle duality. This concept states that particles, like electrons, can exhibit both wave-like and particle-like behavior. Think of a beam of light. It can act like a wave diffracting through a narrow slit, or it can act like a particle carrying discrete packets of energy called photons. This duality is crucial for understanding the uncertainty principle. When we try to measure a particle's position, we are treating it more like a particle, localizing it in space. However, this localization comes at the expense of our knowledge of its momentum, which is more closely associated with its wave-like nature. The uncertainty principle, therefore, reflects the inherent fuzziness in distinguishing between the wave and particle aspects of quantum objects. Section 5. Quantum superposition embracing the unknown. Another key concept linked to the uncertainty principle is quantum superposition. This principle states that a quantum system exists in all possible states simultaneously until a measurement is made, collapsing the wave function into a single state. Imagine a coin spinning in the air. Before it lands, it's neither heads nor tails, but rather in a superposition of both states. Similarly, an electron, before being measured, exists in a superposition of all possible positions and momenta allowed by the uncertainty principle. This superposition principle further emphasizes the probabilistic nature of the quantum world. We cannot know with certainty which state a quantum system will collapse into upon measurement, only the probabilities of different outcomes. Section 6. The microscopic world where uncertainty reigns. The effects of the uncertainty principle are most prominent in the microscopic world of atoms and subatomic particles. At these scales, the uncertainty in momentum and position becomes significant compared to the particle's overall momentum and size. However, in our macroscopic everyday world, the uncertainty principle has negligible effects. The objects we interact with are so massive that the uncertainties in their position and momentum are far too small to be noticeable. Think of a baseball flying through the air. While it technically obeys the uncertainty principle, the uncertainties in its position and momentum are so minuscule compared to its size and speed that they are practically irrelevant. Section 7. Uncertainty's impact, from lasers to quantum computers. Despite its subtle nature in the macroscopic world, the uncertainty principle has profound implications for technology. Many modern technologies, from lasers to transistors to medical imaging devices, rely on our understanding of quantum mechanics and the uncertainty principle. One of the most exciting areas of research is quantum computing. Quantum computers exploit the principles of superposition and uncertainty to perform calculations that are impossible for classical computers. These computers have the potential to revolutionize fields like medicine, materials science, and artificial intelligence. The uncertainty principle, once considered a limitation, is now being harnessed to unlock new technological frontiers. Section 8. The limits of knowledge. Philosophical implications. The uncertainty principle raises profound philosophical questions about the nature of reality and the limits of human knowledge. It suggests that there are fundamental limits to what we can know about the universe, no matter how advanced our instruments become. This challenges the deterministic worldview that dominated scientific thought for centuries. Instead of a universe governed by strict laws and predictability, quantum mechanics paints a picture of a universe where chance and probability play a fundamental role. The uncertainty principle also raises questions about the role of the observer in quantum mechanics. Does the act of observation somehow influence the state of a quantum system? This question remains a topic of debate and speculation among physicists and philosophers. Section 9. Uncertainty and free will, a tangled relationship. The probabilistic nature of quantum mechanics, as highlighted by the uncertainty principle, has sparked debate about its implications for free will. If events at the quantum level are inherently random, does this imply that our actions are also predetermined? Some argue that quantum indeterminacy provides a loophole for free will, suggesting that our choices are not entirely determined by physical laws. Others remain skeptical, arguing that quantum randomness does not necessarily translate to free will in a meaningful sense. The relationship between quantum mechanics and free will remains a complex and unresolved issue with no easy answers. It highlights the profound philosophical implications of quantum theory and its challenge to our traditional understanding of the universe. Section 10. Conclusion. Embracing the mystery. The Heisenberg Uncertainty Principle stands as a cornerstone of quantum mechanics, forever changing our understanding of the universe. This principle, with its inherent fuzziness and probabilistic nature, challenges our classical intuitions and forces us to embrace a new, counterintuitive view of reality. It reminds us that the universe is not a simple, predictable machine, but a realm of profound mystery and wonder. While the uncertainty principle highlights the limits of our knowledge, it also opens up new avenues for exploration and discovery, pushing the boundaries of human understanding and technological innovation. As we delve deeper into the quantum realm, we can expect even more surprises and challenges to our conventional understanding of the universe. Embracing this uncertainty, with all its strangeness and beauty, is essential for unlocking the universe's deepest secrets.